Hi to everyone, myself Dr. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. Today I am going to discuss about corrosion control methods. In this session I am going to cover these topics. First one is different types of corrosion control methods and cathodic protection. What is cathodic protection? In these two types are there. First one is sacrificial anodic protection. Second one is impressed current cathodic protection. And last one is differences between sacrificial anodic protection and impressed current cathodic protection. All these topics I am going to cover in this session. First one is different types of corrosion control methods. In that, first one is proper designing. What is proper designing? We'll see. Corrosion control is achieved by avoid direct contact between two metals by means insulating or by applying protective coating. What is proper designing? Two metals are in contact with each other. Two metals are contact with each other. If these two are exposed to corrosion environment, what happens? These two undergo electrochemical corrosion. So, to avoid electrochemical corrosion between these two metals, we have to apply some protective coating on each metal surfaces. We have to apply protective coating on each metal surfaces. Then these do not undergo contact with each other. So this will not undergo any electrochemical corrosion. In this way, these two metals are to be protected. The second one is using pure metals. Already we know the purity of the metal is more, the corrosion rate is very less. So if you take the pure metal, then the corrosion will be controlled. Then the third one is using metal alloys. What is meant by alloy? Alloy is a mixture of two or more pure metals. Then that is called alloy. Alloying prevents the rusting by combining several metals or elements that interact with each other to form protective layer over the top of the surface of the metal. If our base metal is there, for this we have added some alloy. It contains two or more pure metals. So if these two metals are interact with this our base metal and this form protective layer on this base metal. So in this way, our base metal is protected by this alloy mixture. Use of inhibitors. What is the use of inhibitors? Corrosion inhibitors are substances that are added to small amount, that is 0.1% to the corrosive medium to stop or slow down the electrochemical corrosion on the surface of the metal. Our metal is there. Suppose it is dipped in some corrosion environment. Okay. If we added some inhibitor to this environment medium, the rate of corrosion will be decreased on the metal surface. So that is the way we can inhibit the rate of corrosion by using the inhibitors. The thiocyanocarbazide and its derivatives were used as corrosion inhibitors. Thiocyanocarbazide and its derivatives act as inhibitors in the case of control the rate of corrosion. The applications of protecting groups. A protective coating is a layer of material that is applied to a substrate to prevent from corrosion. This is a metal is there. If you apply some protecting groups like grease or oil, in this way we can control the rate of corrosion. The cathodic protection. What is cathodic protection? We'll see. The method of protecting the base metal by forcibly making it to behave like a cathode, thereby corrosion does not occur, is called cathodic protection. Already we know, if metal is exposed to corrosion environment, what happened? It acts as anode, undergo oxidation, it will be corroded. So we have to convert this metal to cathode. Then the corrosion will not take place for this metal. If it acts as anode, then only it will get corroded. Why? Because it undergo oxidation and it will be corroded. If we convert this nature to anode to cathode, then it will act as cathode. Then there is no electrochemical corrosion on this cathode. So in this cathodic protection, we have to forcibly change this metal to the convert into cathode. Okay, by this making cathode, we can protect our base metal. The cathode protection is two types. We can make the base metal into cathode by two methods. One is sacrificial anodic protection method, and second one is impressed current cathodic protection. First one is sacrificial anodic protection method and impressed current cathodic protection. By using these two ways, we can convert the base metal into cathode by applying or without applying current. We'll see. Sacrificial anodic protection. In this method, we'll see what happens. In this protection method, the metallic structure to be protected. The metallic structure means our base metal is protected by connecting a wire to a more anodic metal. Our metal is there. We have to connect these two and one anodic metal. It is anodic metal means this is cathodic metal. How we can identify this anode, this is cathode? We'll see. We have to connect to the anodic metal, means we have to connect if our base metal contain some reduction potential, let's say 0.2 volts. We have to connect this base metal to contain more electrochemical reduction potential electrode. Then it acts as anode, means we have this metal should contain more than 0.2 reduction potential. Then this metal acts as, this electrode acts as anode, this acts as cathode. So if these two metals undergo corrosion, in this method, if it is exposed to electrochemical corrosion environment, this acts as anode. So it will undergo corrosion. Our base metal acts as cathode. It will be protected. Okay. In this protection method, the metallic structure to be protected is connected by conducting wire to a more anodic metal. We have to connect our base metal to more anodic metal. That means more reduction potential content electrode. Then that other metal acts as anode. Our base metal acts as cathode. Then only our cathode metal will be protected. So that all the corrosion is concentrated this more anodic metal. Okay. What happens in electrochemical corrosion? Electrochemical corrosion, at anode, oxidation takes place. These two metals are there. This is anode. This is cathode. When these two are exposed to the corrosion environment, this anode acts as, this anode undergo oxidation and it will be corroded. This acts as, our base metal acts as cathode. It will be protected from the corrosion. So the corrosion is concentrated on the only anodic metal, not on our cathodic metal. The more anodic metal itself gets corroded slowly, while the parent structure cathodic is protected. In this way, the anode acts as undergo oxidation and it will be corroded. Our base metal acts as cathode, it will be protected. The more active metal so employed is called sacrificial anode. The more reduction potential contain metal, that is anode acts as sacrificial anode. Means in this way, this is sacrifice its life to by the corrosion, undergo corrosion. So this is called sacrificial anode. It sacrifices its life to protect the cathode. That means our base metal. The corroded sacrificial anode is replaced by fresh one when consumed completely. If this electrochemical corrosion undergo several days, then anode always continuously acts as anode continuously undergo oxidation. It will be corroded. After some days, this will be corroded completely and disappears. So time to time we have to take fresh anode, and when it is consumed completely, when it completely consumed, anode when completely consumed, we have to take fresh anode in this method. The artificial made anode thus gets corroded gradually, protecting the original metallic structure. Hence the process is known as sacrificial anodic protection. Why we call this is sacrificial anodic protection? The anode continuously undergo oxidation, it will be corroded and it will be protected our base metal by access the anode and it will access cathode. In this way our base metal will be protected, and here the anode undergoes sacrificing their life. So this is called sacrificial anodic protection. Metals commonly employed as sacrificial anode are magnesium, zinc, aluminum and their alloys, which possess low reduction potential and occupies higher end electrochemical series. The metals which contain low electrochemical in electrochemical series, the metals which are placed at higher top of the electrochemical series acts as anodes. So magnesium and zinc and aluminum, these metals acts as anodic sacrificial anodes. Example: a ship hull which is made up of steel is connected to sacrificial anode, that is zinc blocks, which undergoes corrosion, leaving the base metal protected. This is the ship is there. In this ship we have connected one zinc blocks to this ship. This is the steel surface. Okay, this is steel and this is zinc. It acts as anode, sacrificial anode, and the remaining part acts as cathode. If it is exposed to corrosion environment, this acts as anode, undergoes oxidation. In this way, this steel part will be protected from the corrosion. The second one is ground level. In C, ground level. This is the buried pipeline. Internal cathodic protection of pipeline by sacrificial anodic method. See, inside this iron pipe, some blocks are there. These are magnesium blocks. The iron pipes are connected with magnesium blocks. These magnesium blocks act as anode and the buried iron acts as cathode. In this way, magnesium undergo oxidation and it will be corroded, and the cathode part means our pipeline will be protected from this sacrificial anodic method. This is the external cathodic protection of water pipeline by sacrificial anodic method. See, we have in this internal, our anode is connected internal to this our pipeline. But in this case, the anode, that is magnesium blocks, are connected externally to this pipeline. This is the external cathodic protection of water pipeline by sacrificial anodic method. The applications of sacrificial anodic protection. See, what are the applications we have with sacrificial anodic protection? By referring to the electrochemical series, the metal which low reduction potential is connected to the base metal which acts as anode. In the sacrificial anodic method, we have to connect our base metal to the metal which contain low reduction potential volleys. Then it acts as anode, this acts as cathode. In this way, our metal will be protected. To protect underground pipelines, buried pipelines protected by connecting to the magnesium block. In the last slide, we have seen our buried pipeline will be protected by connecting to the magnesium blocks. Protection of ship hulls and other marine devices. By this way, we can protect the ship hulls or some marine devices. We can protect it by using sacrificial anodic protection. The third one is protection of water tank by suspending zinc or magnesium rods and body of the tank made cathode and protected. If this tank is there, iron tank is there, if you want to protect this iron tank from corrosion, we have to suspend zinc or magnesium rods inside this tank. These acts as anodes and our tank acts as cathode. So in this way, our tank will be protected from the corrosion. The advantages of sacrificial anodic protection. See, what are the advantages of this? First advantage, it is simple method. The sacrificial anodic protection is simple method. And second one is, it does not require external power. The sacrificial anodic protection does not require any external power. The third one is, it has low maintenance and installation cost. There is no installation cost and maintenance cost for this sacrificial anodic method. What are the disadvantages of the sacrificial protection method? We'll see. First one is, more than one anode is required sometimes. If corrosion takes continuously, we have to change the time by time our anode metals. So it requires more anodic metals. We have to change the more anodes in this method. The second one is it does not work properly in high corrosion environment. If the environment contain high corrosion nature, then in this case the sacrificial anode method will not work. The third one is sacrificial anode must be replaced periodically as and when it is consumed. Already I explained. If corrosion takes continuously, means several days if it takes, the anode will be corroded and it consumes completely. Then we have to change or replace that anode by time to time. Then only the sacrificial anode protection work. Otherwise, our metal access anode, that our base metal also will be corroded. The impressed current cathodic protection. What is the impressed current cathodic protection? We'll see. In this method, in the cathodic protection method, in impressed current cathodic protection method, an impressed current is applied in opposite direction to nullify the corrosion current and convert the corroding metal from the anode to cathode. In this method, what happens? We'll see. This is our base metal. We have to connect our base metal. This is our base metal. We have to connect these to the neutral metal, that is the graphite. Okay, by wire. Okay, so it is exposed to some corrosion environment. These two metals are exposed to some corrosion environment. What happens? The electrochemical corrosion occur in this case. So some electrochemical current, means in this one acts as anode, other one acts as cathode. So electrons moves from anode to cathode. In this way, some cathodic current is developed inside the electrochemical cell. So this is called the corrosion current. This current is called corrosion current. So we have to apply some external impressed current. We have to apply impressed current to nullify this corrosion current externally. So these are two. This is our base metal and this one is graphite or neutral electrode. Graphite or neutral electrode. This is our base metal. Our base metal will be protected by this way. See, we have to connect some external power. We have to supply some external power to these two. These a positive terminal connect to this our base metal and negative terminal connect to this neutral metal. So in this way, actually before connecting to a power supply, in this some corrosion current is there. From electrons moves from anode to cathode. To nullify to this corrosion current, we have to supply some external current. In this way, the positive terminal connected to this our base metal. So our base metal acts as cathode and this neutral metal acts as anode. Okay. See, the impressed current is slightly higher than the corrosion current. Our external current or impressed current is slightly more than compared with the current developed in the electrochemicals. That is corrosion current. Thus, the anodic corroding metal becomes the cathodic and protected from the corrosion. In this way, our base metal acts as cathode, the neutral metal or neutral electrode acts as anode, undergoes oxidation, it will be corroded and our base metal will be protected. The impressed current is taken from battery or rectifier and DC line. We have to supply external current from DC line. The negative terminal of DC source is connected to the anodic or like graphite. Our negative terminal connected to the neutral or graphite electrode. The positive terminal of DC source is connected to the metal structure to be protected. That is our base metal. The positive terminal should be connected to our base metal. In this way, our base metal acts as cathode and the neutral metal or graphite electrode acts as anode. From DC source, the electrons flows to the metal structures and as a result, it acts as cathode. This is our base metal. We are connected to the positive terminal of the DC. So, this positive terminal DC supply electrons to this our base metal. So our base metal acts as cathode. Our base metal taking electron from the DC. So it acts as cathode. The mechanism of converting the metal structure into cathodes in order to prevent the corrosion is called impressed current cathodic protection method. In this method, impressed current cathodic protection method, we have to supply some external current and our base metal acts as, we are converting our base metal into cathode. So in this way, we are protecting our base metal from the corrosion. What are the disadvantages of this impressed current cathodic protection? The first one is, the method is expensive as it requires high current. This impressed current cathodic protection method is very expensive. Why? Because we have to supply some external power. But in case of sacrificial anodic method, we no need to supply any external current. That is the very easiest method and costless method. But is the impressed current cathodic protection method is very expensive. Why? Because we have to apply some external energy. So this method is expensive and requires high current. The capital investment and maintenance costs are more. The capital investment, the cost and the maintenance of this impressed current cathodic method is very more. It is difficult to maintain uniform current over the entire metal surface. As result, localized corrosion may be occur. This is if large metal is there. Our base metal is very large. So if we connect it to the external DC, okay, what happens? The uniform current will not take place. So if you take the current flow up to here, there is no power supply up to this metal. So current power supply is limited to up to here. So this metal acts as, up to this it acts as cathode. The remaining part will not act as cathode. It may act as anode. So result, localized corrosion may be occur. Means this part will undergo corrosion. So the localized corrosion may occur in the case of impressed current cathodic protection method. Differences between sacrificial anode method and impressed current method. What are the difference between sacrificial anode method and impressed current method? We'll see. This is the sacrificial anode method and this is the impressed current method. Metal structure is forced to behave like a cathode by connecting to more active metals or anodic. In sacrificial anodic method, what happens? We have to connect our base metal to the anodic metals, means which contain low reduction potential values. So in that way, our metal acts as cathode. Our metal will be protected from the corrosion. But in case of impressed current method, metal structure is forced to behave like a cathode by sending direct current. In this impressed current method, you have to apply some external power to this our base metal. Then only our base metal acts as cathode. For example, magnesium, zinc or aluminum are used to sacrificial anodes. Ship hulls, water tanks, buried pipes are protected. In electrochemical series, top of the electrochemical series, these metals are present: magnesium, zinc and aluminum. These will have low reduction potentials. So these will act as anodes. Okay, undergo oxidation very easily. So these acts as sacrificial anodes and these can be protected. What they protected? Ship hulls and water tanks, buried pipes are protected by using this sacrificial anodic method. But inert anodes like graphite are used. Buried pipelines, towers, water pipes are protected. In the impressed current method, our base metal is connected to the neutral electrode, that is graphite. Okay, then we have to supply external power, then only it will work. This acts as anode and our base metal acts as cathode. These, by using impressed current method, buried pipelines and towers, water pipes are protected. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.